Welcome to the third meeting of the R user group. So today we've got James and Tak here from University of Otago, the Wellington department. So the Wellington session. to talk about Knitr and Sweave. So without further ado, I'll head over to James and Tak.
Thank you. Thanks everyone for having us. Tak and I are going to co-present this session. So I'm going to start off by talking about just a few issues about the kinds of things you can do with Sweave and Knitr and some few sort of top level issues with that. And then Tak's going to run you through a couple of examples that we have just tested, and they did actually work this time, thankfully. So it will hopefully be a relatively error-free run through. We've left plenty of time for questions, so if people would like to ask questions as we go through, with that. Neither of us would claim to be experts in what we're about to talk about, so it's more to show you some of the kinds of things that we do and some basic bits and pieces that can get you started if you do want to be creating some of these dynamic documents. Contact details are just on this first slide, so if you'd like any further information, just let us know, and when we get organised we'll try and put the slides and so on and some of the example scripts somewhere where people can get their hands on them as well. Okay. So what we wanted to talk about today are really just a couple of different tools to achieve the same end, which is thinking about reproducible research. So, and I guess what you might broadly call literate programming. So the idea is to be creating a document that's a synthesis of not only your data analysis plans, so using code to document the kinds of things that you want to do with your data analysis, but also the code itself and the output on top of that. So I mentioned that those of you who've been working with R and statistical methods more generally for a long time will have strategies that you use for putting documents together that will be a blend of all of these things, so the decisions that you made as to what you want to do, how you actually went about doing it, and the output. So this, in many ways, one of the prime functions of using something like Sweave or Knitr is to cut down on double handling of your outputs. So essentially you can have one file that will include all of the information that you have. You know where all of your code's sitting and that it's pointing to all the data and so on and so forth. So integrating and simplifying things somewhat. So how do they work? Sweave and Knitr in a lot of ways do exactly the same thing. We'll go into some of the technical details of how they differ a little bit later on. But in terms of their overall structure, we're really programming with a mixture of R code, as you would hopefully expect, this being an R users group, LaTeX commands. Just out of interest, how many people here have used LaTeX before? Okay, that's good, a lot of people. If you haven't, the good news is that actually with relatively minimal overhead, you can get some pretty nifty sectioning commands and so on under your belt to be able to put together the structure of a document pretty quickly. And then the last part, which is specific to Knitr or Sweave, are the different what we might call package options that we might specify for a particular chunk of code. So knowing how to set particular commands to set the size of a figure in a particular section of the document, say to be 3 by 3 inches. So generally speaking, files are structured when you're creating the file to run. Files are structured as a LaTeX specific header, and from my perspective as someone who switched from using Word to LaTeX for my PhD thesis about 10 years ago now, wrote one paper in LaTeX, and once it was accepted, got told please send us a Word copy of your document for copy editing, and didn't really get back to LaTeX for quite a few years after that. This is the hard bit for me to get my head around again, is the LaTeX header aspect. Thankfully, there are some relatively simple things that you can do, especially using RStudio, that will make your life a lot easier in terms of getting that header part right. So once you've got the LaTeX specific header basically everything else that might happen between the start and the end of your document could be considered to be a big LaTeX document. So you could just type completely plain text in there with line breaks and no other bells and whistles, and what you get out of the other end will be just a nicely formatted textual document. So where we start to get into the more useful stuff is these interspersed R code chunks and LaTeX segments. So alternating between descriptions about the kinds of things we're doing in our analysis and the actual output, the code and the output itself, formatted in line. So here is a very simple example. This is technically in Sweave. Not quite sure which screen is best to look at. Oh, this one here, just because I'm working on this side. So you can see the header bits at the top. So the most basic header that you can have for this kind of file is literally just 2 lines. Document class, so it's a LaTeX header command telling you that this is an article as a type of document, and then begin document. So everything between begin document and end document here, you could just literally have some text in there and that would compile as a PDF file. The Sweave option is needed for running Sweave, but I'll come back to that a little bit later on. So what we have underneath that is, first of all, just a line of text, so just some nonsense there, and then between these little greater than, less than, equal signs here and the @ sign down here, which probably doesn't show up very well, there's some R code. So in this instance, just 1 + 1, so I don't want to get into the details of the statistical side of things too quickly. In RStudio, thankfully if you click a button, you do get some useful information out of it. So at a simple level, in terms of getting a document up and running, if you literally just have some R code that you're sticking in that R code chunk section, you can just get your output really dumped very quickly to a PDF. So if you just want a working document of, this is all the stuff I did today and I don't want to have to worry about how I'm sticking it all together, I mean, it's a very simple use of this kind of thing, but it's actually quite useful from a day-to-day point of view to be able to do that. So in terms of when this gets to be a little bit more useful than this, when you want a single file that's documenting your whole data analysis process, so from strategy through to execution and conclusions, for instance, it's really handy. So I've used it actually going through my files to check on what I've done, not as often as I thought I had over the last year or so, but I've used it a lot in a consulting role at the medical school. So if people have a research question for us, it's a nice way to just kind of get everything in one file that can be easily sent to the person who's asking for some data analysis. And the main advantage really is in being able to rerun things that you've run in the past. So if you're working on some iterative data analysis where you might do some analysis, send it back to someone and say, hey, well I got through to the point where I was just looking at some cross tabulations of variable A and B, and it looks like there are all these people under the age of 12 who say they've got 3 kids, so you know what's going on with your data cleaning. You can update your raw data file, for instance, and then just run your script again. Also, if you're running the same kind of analysis, so if you're in a reporting environment where you're running the same kind of analysis lots and lots, then it's a nice structure for dealing with that, where it would be relatively easy to update the raw data that's going in to your R analysis and getting a nicely structured report out of the other end. So I must admit that I've never really tinkered around too much over other ways of getting integrated output from R. But in my opinion, the main advantage of this over code with ample annotations is that you get nice inline formatting, you get your code and your output and your figures in particular formatted inline in the document that you have. So in many ways, it's a convenience function for me, being able to use these things. And so PDFs are very easy to share nowadays. So being able to get a PDF essentially at the click of the button is very useful. Just a little bit of terminology. So the woven document that we're going to end up with is really the end result of all of this output. So in the instances I'm going to show you, it's a PDF file, but because we're talking about LaTeX, if you want an EPS file or a PS file, you can do that as well. So that's the document that has the interspersed text, code, and console output. If you do have a .rnw file, so the source file for creating a woven document from, you can also do what's called tangling the document, which essentially goes through and pulls out all of the chunks of R code and puts them in a separate file. So if you want a standalone file that just has all the data analysis bits, you can do that as well. In terms of times when that might be useful, it might be, for instance, if you've got a data summary report where you need to create a whole set of derived variables, for instance, instead of just sort of copying and pasting over the bits of code that you need, you can sort of dynamically get R to generate all of the R code from your original file and then use that as the basis for your subsequent analysis. I've already gone over this really, so times when woven documents are useful. So I don't think there's necessarily anything more to add on that. So I'm just going to show you a file with almost zero statistical content in it. So this is the file I'm about to show you is a data cleaning report from an HRC project that I've been involved in. So just to give you a very quick précis of the study, it was a study looking at informal coercion among psychiatric care outpatients. So these are people who are being seen in the community and asking them questions about whether they felt that they had been informally coerced is the psychiatric field term, so in other words, non-legal coercion to go on with treatment. So being told, well, if you don't keep up with your treatment, it's possible that you might lose your accommodation or your benefit maybe stop your work. So in terms of why I created this document, at one level we needed to go through all the data that had been entered by the research assistants and check it was all there and it was all making sense. And also the project leader wanted just some simple univariate summaries of all the responses in the survey. So just give me 2 seconds. So this is the document here. So at the moment this full report runs to something like 174 pages. So in the days of iPads and whatnot, it was actually very handy just to have a quick, easy PDF version of this document. One nice thing that Sweave and Knitr does is that when you have section headings, it also gives you quick links to those, which is really handy from sort of browsing around the document. So this is relatively, this is not a particularly attractive looking document, but the main aim was to get a lot of information into an easily handleable document. And also you can see some bits and pieces in here where we've had a meeting about what are the problems with this particular set of data and what we're going to do about that, so we can document all that in one place and add to the document later on and reprocess things.
So what are all those other files there, James? Is that part of Knitr, or is it?
In this one here, these are. I'll show you one of these. I'll show you one of these now. What I actually did was, because this was quite a long survey. It was like ran to about sort of 30 to 40 pages, A4 pages of coding sheets for the responses. I actually worked through it in sections, so I actually made one file for each section and stuck them together at the end, just so that I could maintain my sanity doing the coding. And then I stuck them together at the end. I might leave this for Tack to talk about in a minute, but you can just see in here there's a mixture of LaTeX commands. So this is just plain text to come through, and then down here are the commands for calling view functions and down here. Yeah, and there are a lot of files because there are a lot of questions. And this is actually relatively clean. Once you run Sweave in a particular folder, you end up with all the auxiliary files and whatnot, and text versions of your files and so on. So it can actually get pretty messy from a folder point of view. That's the one downside to it. So just to talk, I'm not going to talk very long about Sweave versus Knitr. Sweave is reasonably old now. I don't actually spend too much time trying to tie down entire dates, tie down accurate dates to things, but Sweave predates Knitr by quite a few years. In general, the overall process for laying out a file is the same. So if you've learned one, you'll be able to switch easily to the other. And Tack might just have a few words to say. If you have used Sweave before but want to convert a file to Knitr, there are some quite nice functions in the Knitr package that will convert your document for you as well. So from a programming point of view, the main differences are in the file header. So you do need a few more options in the LaTeX file header like the Sweave option we saw before, than in Knitr, and in the R code chunk header. So I'll leave that for Tack to talk about in a second. But if you want to hide the output from a particular chunk of code, there's just a different way to specify that in Knitr than in Sweave. My understanding is that firstly, Knitr claims to be more modular than Sweave, so more easily expandable and sort of fixable in that respect. But also some of the chunk heading options, the way that you specify those options is more in line with standard R practices. So if you're passing the character string as an option, that needs to be in inverted commas. Whereas in Sweave, for instance, if you want to hide a particular section results, you just have to hide in plain text. The main difference that I found between the two is that Knitr handles figures a lot more easily than Sweave does, which I think is a major advantage actually. In fact, if you just run some relatively plain Sweave code where you're drawing some figures in your sections and don't have a header option to say, hey, include the figures in this section, you won't get any figures in, and it's the kind of thing that can lose you a fair few minutes when you're starting out with these things. So getting set up is actually pretty quick. You need, perhaps obviously, your R installation. You also need a tech installation. I've just used MikTech for this, just out of parochial. It's what I first used, and I haven't really needed anything more complex since.
So that's a Windows environment you're working on, is it?
It is Windows, yes. So if people do have comments on what works better for other
something else is you could use in Linux.
Yes, I think it's just basically you need LaTeX up and running on your machine.
Yep. Text Live. Text Live.
Thank you. Sorry, obviously sitting in front of my computer, I'm thinking about other people sitting in front of different computers as well. You sometimes might need some additional tech packages that the first time you compile. So as per most things, if you're running on a system where you need admin privileges to install things, it does tend to lead to a few problems with some things. Sweave is part of the base R installation in the utils package. Knitr needs to be installed separately, but just the same as any other package. So this is possibly a moot question for most of the people in the audience, having used LaTeX before. I think you can actually get by, in terms of making a structured document with Knitr or Sweave, with relatively minimal LaTeX. If you know how to specify a section heading and subsection headings, and basically put emphasis, bold font or italics on particular bits of text, you can probably do most of the things that you want. If you already know how to make tables, you can make things look nicer and so on and so forth. But I think really the sectioning commands are really the most useful. I'm just going to mention RStudio relatively quickly, although we'll show our examples within RStudio. The main reason to mention RStudio is that actually it's got some nicely integrated Knitr and Sweave functionality in it. So if you're working with a .rnw suffix file, there'll be a nice button on it that we'll see in a second called Compile PDF. I do have some notes in a second about how to for those of you who don't use or don't want to use RStudio, about how to manually compile a Sweave file. You basically, in the case of Sweave, I haven't actually got the notes on Knitr because I've never done it before. In the case of Sweave, you simply call Sweave on the .rnw file that you run. That creates a .text file from that, and then you run LaTeX on the .text file, which you can call from within by point. Other nice things about RStudio are that if you ask for a new file for a Sweave document, that will automatically put the headers in there for you, so you can basically just start typing between those and start putting your code chunks in. So it's relatively quick to do. And if you are a LaTeX newbie, then you can get some drop-down menus for different things. So if you can't remember what I need to use to get underlined or bold or whatnot, you can just select that from a drop-down menu and fill in the space between the curly braces. One other useful point, which is possibly not true of running this in just the R GUI, is that within RStudio, when you compile your document, it actually compiles it in a separate environment. So if your code that you've got in your .rnw file isn't standalone, so if you've done an intermediate step in the console and you've forgotten to put that into your .rnw file, then it's not going to work and it will fall over. You may not spot that because it may be an error file hidden somewhere in your PDF file, but it's not going to use objects that are in the standard environment. And I think that's quite a useful feature as well. I'm going to hand over to Tech now to show you a couple of examples. So Tech's got a quick example in Sweave and then a quick one in Knitr as well. The Knitr example uses stuff from the survival package. So this isn't analysis that we've been doing ourselves, but hopefully it also means that the file documents are going to be easily reproducible and shared.
Good, so I'll just start with this. So I'm Jack. I'm not really a biostatistician for that long. I haven't been, sorry. But I'm learning slowly from James and another guy. I did start with using LaTeX separate from R, doing master's thesis and PhDs and stuff. Sorry, one PhD. But I was doing it in Linux, so it wasn't really related to this at all. But I started Sweave after James said, you should try, it's cool. So quickly I learned, it's pretty easy, not easy, but enjoyable to learn from a programmer's point of view. And then just recently, after volunteering to talk, I learned Knitr today, which is pretty funny. But I'm officially switched over to Knitr from today. But I'll show you a simple resume intro. So that was my, I'll just start with a, see if this works. So this is the Sweave. I'll just do the Sweave one first. Try to do it in 5 minutes. Hopefully everything works. So, okay, so you know all the stuff that James has talked about. So, some people don't know LaTeX, but you just have to kind of pretend that you do. So there's certain packages that you need to run the script in LaTeX, and those come at the top. I won't really go into what they are, but just things that you need to do specific things. I'll just leave it at that. The actual document starts, begin document. And I'll try to do one section at a time. At first, I'll show what it gives you. So this is, I'll show you what this magical button does. It says compile PDF. And if you press it, it does all this stuff and shows you your PDF. And that's not an error, that's an image. But, yep.
So you might zoom in.
Is that okay?
Mm-hmm.
Okay. So that's the top. So everything is quite formatted nicely. You can change it in your own way as you want, but certain things can be dynamically changed, like the date, for example. If you just write today, I think it puts in the date of today. You don't have to type in December 17th. That's one. Just start here. This is just one thing that I found troublesome before. It was yesterday. But you can't have spaces in your R and W file, like the name. I don't know. You know what?
Probably just when you're calling things on command line, spaces tend to be automated.
Okay. Something in the background is not liking the spaces. So you have to make a file that's no spaces or those things, underscores. Yeah. So that's what I usually do. I'll just quickly go back to the here. So this is the where the argument starts, and between these sort of brackets, you can put in a few options, and options that it changes the output of what you see in PDF. So echo F, basically it shows kind of the output of the command, but not the command itself. Okay. So the 2 bits here, sorry, it's not, I'm not talking about. The first line is just that's a concat.
You're doing great, Tate. You're doing good. Don't worry about it. You're doing good.
Okay. So the cat function, I forget what it said. But it's just text within R. Okay. And then it's just for your new font. But then I guess the default font is Times or something. But from here, from the make sure no block, is the actual LaTeX command. So we don't have to go into what I wrote, but so the R code ends at the @ mark. And then after the @ mark, you put in text, but you write it in a way you can write text, just normal text, but it'll be a bit boring. Not boring, but not cool. So if you write it in with special, what are they called? LaTeX commands, I guess, that start with a slash, backslash. It makes things bold or italic or really big or really small. Okay. And is this okay?
Yeah, it's good. You're doing good.
Okay. So I guess we can start with just a really simple example of some data I took from the internet. Just looking at height and weight of people. Not that interesting, but simple. So the first thing you need is a few packages, of course. These are the two that I happen to use for this example. And you read in the data, you show the data. So up to this chunk here, you read in the data and you show the data. And so it doesn't, so it shows it hides the results, so it doesn't show the output. Sorry, it says results hide there. With the next part, say, for example, this one, this one has nothing in between the brackets, so it's basically, I guess it's the default where it shows everything. So it shows the command and the output, so it's just the first 4 rows of people that are taller than 70 inches. So that's the 4 lines here. And then just one thing on this aside, but writing LaTeX, the word LaTeX, it's a function in LaTeX, and it gives you this cool thing. I don't know, trademark thing. So I did do some simple steps, I guess. So I did convert things to more comfortable units, so centimeters, meters, and kilograms. Just creating things with the data frame, and calculated EMI. So this thing here is a equation. You know, LaTeX is easy, but it's this part here. So you just put in an equation, and so this is, I guess you can write it in text, but it'll look horrible. So you use like a fraction command and other curly bracket functions, and then it makes a a little segment for the formula. And cool enough, it gives you the number to make reference to. So this number 1 here is automatically put in, and so that's a LaTeX thing. Moving on, we'll just go to the figures, I guess. There's 2 ways to put in figures, or there's more, but I'll just show you 2. The first one is just showing output of what you see in R. So that is this section here, subsection. This chunk here is, it doesn't show the command you type in, so echo equals false, and figure equals true means you can see the actual figure that's in the R plot window, I guess. So that would be this, and I didn't set any options, so it's big, it's a little big, but that's the default, what you see in R.
If you did want to set options, do you put them in between the
Yeah, so you can put it in between, I believe you can put it in there. Can you put it in Sweave? I didn't.
Yeah, it's been ages since I've used Sweave to change, so you can change like global settings for figures. In Knitr, which is a lot easier generally for figures. You can set a global option for figure size and then a chunk specific option. So if you only want to have like a 2x2 size image in a particular chunk, you can set that just in the header for the chunk. I'm sure you probably can in Sweave as well.
Yeah, you probably.
Width and height.
So
Cool.
it's you can type in. So the cool thing about RStudio is that it'll help you if you're in trouble. So like now, trouble. You can look. Oh, sorry.
Cool.
Something like that. Yeah. But let's say we don't do that. But in Knitr, it's quite relative. It's a little easier than Sweave. This isn't the way I usually do the figures. It's the next part here. So, yeah, so that's that. You can actually put, the way I do is I export it to a PDF and then I read it back in, which is a bit tedious, but I think Knitr does it more elegantly.
You got a reference to a fig, so
Yes.
you got /ref fig
Yep.
history. Do you need to define what is fig history, or does?
Yep. So I'll show you in a second.
Okay.
It's not history, it's histogram, but it's okay.
Oh, sorry.
But it's okay if you have the reference command before the actual figure. It's pretty cool. So the actual LaTeX part is here. A few commands here and there, but basically I exported, sorry, I should say this first. This is the R command using the Pyro package to export PDF as some height, width dimension, and that's exported as a PDF, but it doesn't open in RStudio. But then you read that back in with this begin figure command, and I just, so you can put a caption in, which is like just the title, and this label, which is what you asked. The label is this. You don't have to use colon or anything, it's just a good standard thing. But if you put in a label inside that segment, that section, and if you make reference to it up here, it'll give you the same, figure 1, but I think it's figure 1, in your output. So we'll take a quick look at the output for now. Okay. We'll go down. So I set it as a different width and different height, obviously, so it's a little different there. But here is figure 1, and here, here, figure 1. So they match. If you ever put a figure in between there, it'll change to 2 or something like that. And it changes dynamically. So that's pretty. So the same thing. You can do the same thing with tables too. Tables is a little different because it's text, but let's go back. I think I'm gonna use up all my time on this week. It sucks. But okay, so the table. Let's say we want to just look at the summary of the data, and looks in R. It looks like this segment here. Oops, you saw the better version, but that's what you basically see in R. And it's fine, but if you want things that look a little better, you can. It's not really better because it's not really like. Sorry, it's this segment here. So this part uses a package called X table, or I think that's sort of how you read it. But it's you can take a table output. And then if you use the X table command, it makes it into a LaTeX format, so it ands and slashes and all that. So you don't have to intervene in any way. And so this chunk here, the options are, you don't want to see the command, so echo F, echo false. And then this result equals text is another option where it shows the text. Text is for LaTeX, but it shows the LaTeX output, and then treats that as a LaTeX, rather than R language. So this output here, this output here is I guess it's not the standard, it's like the default layout for a table.
Cool.
Oh. Okay, so this simple model here is a bit silly, but I'm sure everybody knows what happens. But I'll just talk about, so I already talked about weight. So I wanted to see what the relationship was between weight and height, just to be simple. And so this model here, in summary of the model, can't really tell what happens, but so it shows you the command, it shows you the output here, and lucky enough, get positive beta there and significant stuff like that. So you can show all of the output by default, or you can save summary bracket m as an object and just show separate parts of it if you want. So you can put the whole thing. Yeah, it's funny because I made an example data set and it didn't work. Not work, it was not significant, so I started from scratch. Okay, next bit is, oh yeah, just the next thing about the model is it's the same thing. The figure for diagnostics, and I just did it this way, using the Knitr package and reading it back in here.
Is there a reason why you do that?
I just like it.
Okay. Good reason?
One of the reasons is if you want to use the nice LaTex environments, I think this is the only way you can achieve that in Sweave. In Knitr, you can pass header chunks where you give captions and labels to things, which is possibly a little bit tidier to do. But
yeah,
Sweave,
so
I
I liked it because I used to use Sweave till this morning, and yeah, I just prefer it this way. You'll see that Knitr is a little better in that way. And that's actually it. It took a bit long to go through all that stuff, but you have your nice QQ plot and all that stuff.
I wonder if all your plots come into one page.
You can make it fit by changing this. Yeah, you can do that. I just forced it into a 3x2, but you can use packages that put figures together more nicely. So figure.
So you rely on LaTeX to do it rather than using R.
Yeah, that's what I do. There's probably a few ways to do it.
Yeah, I guess if you're doing some kind of lattice plot, then you might just, if you need the graph to be big enough to read, you might need to just do subgrouping and plot individual plots.
You can turn the page to landscape with the landscape package, I think. That's a LaTeX package. And then you switch it back. Oh, I've had lots of questions. But yeah, there's many ways. There's a few ways to do one thing. You just gotta find it or ask someone who knows. So yeah, and this thing, session info bracket, is something that James uses. And I thought, well, that's pretty cool. And tells you what you use and what packages you use and stuff. So I didn't know this function. I've been using R forever, but didn't know that function. I'll go to the Knitr one. It's a little.
I could just do the
okay,
differences for that one if you want.
Okay.
I just think, because I wrote this one, I'll just go through and just point out the differences.
Oh, can I just do one thing? Sorry.
No, it's all good.
So I did this Knitr. I saw his example and I thought, oh, Knitr is so cool because the output it just looks way better. And so I changed my Sweave document as a Knitr one. I've been using Sweave for like 2.5 years, and I used Knitr for an hour and successfully converted it. And then just before leaving, I found a Sweave to Knitr command that's in the Knitr package. But anyway, it's okay. But so this cool. It looks like that, right? So your R commands and your figures and output all in one color. but I'm sure that's compiled. Yeah, we haven't compiled it yet. Okay, I'll show you the Knitr version later. Or
Cool.
maybe. Anyway, sorry for that.
Can I ask one question? You've plugged in all your fragments of our code at the appropriate places where you wanted them. I think an option you could have is to keep all your code together in a file and reference it, to delineate the chunks as appropriate, but keeping it all in one place has some appeal too.
Yeah. So the reverse process to that is a tangled file where you take this document and split out all the R code. But I think in Knitr they're called child documents. So you can essentially have chunk identifiers, so a file that's just R, and you say, in this document here you've got all your text description, and you say, hey, go to my other file and find section univariate analysis, and put in that code and the output there. So you certainly can do it. I haven't tried that yet.
Yeah, I've tried that.
Okay.
I've actually gravitated. I started that way, and then I gravitated to doing that more.
Yeah, it's because when I first used this, I pretty much started off with my R file from Woe to Go, and then chucked all the other stuff in around it. But it doesn't mean that you have to then go hunting around through all this other stuff. It does get visually, it's quite messy on the screen to see what's going on.
What would be the easiest way to organize your LaTeX R combination document if you wanted to give somebody just the LaTeX code plus the graphics, nothing about the R code at the time?
So you literally just want you really just want the output tables and graphics,
Yes, but
and
not
the
any of the
description.
R code.
You could you could turn on echo equals false, so that will turn off the echoing of the
Global
commands.
options turn all echoes off.
Yeah, so you can,
But
and then
if
you
you
can just,
didn't want to reveal the R code section, you wanted to give a file that has only the LaTeX command and then the graphic file.
yeah,
How
you,
would that do that more easily?
I think, sorry,
Isn't there a .tex file that comes out after you compile it?
there is, so there is an intermediate step where a .text file is created, so you could, one option would be to edit that. Another option would be in this file here is to just split up your code chunks into the secret bits and the bits that you want to show to people. So you could create your objects, so your figures and tables that you want to show in one chunk of code that's never printed at all. And then in your second one you could just call print to print those objects, for instance. So your working file would have the production code and then this little bit down here that just prints the output. But in terms of what you're giving to the other person, it would just be the document with the text and the relevant output you wanted to print. Does that sound like the kind of thing? Yeah. Maybe it's just laziness, so I tend to leave the R code in rather than edit it out, because then when I meet with the person, I can actually, it's all there in front of me and I can kind of see what I actually did.
Can I just make another point? You wanted a PDF output, so you had to do later. If only you wanted an HTML output, you could have done Markdown, and you would have a much simpler exercise, which is I found a really good way to start, because I find Sweave, or at least LaTeX, is relatively complex and tedious compared to Markdown, which is almost trivial. And so you can do exactly the same parallel thing, embedding your R code in your documentation, using Markdown and ending up with HTML.
Yeah, that's true. I guess as statisticians often do, when you know the complex solution already, you tend to apply it to the simple problems. But that's a good point, especially for starting out.
And of course, Knitr can do both. So when you're using RStudio, you just select Knitr as your engine, and you can do both. You can have a Sweave or what is it? RNW document or a R Markdown document.
Okay, great. Cool.
Yes. Yes. We have seen a number of examples showing a paragraph of text, a paragraph of R code. Can we pass the output inside the text? Say here is an example. This example is just something output from the R, rather than one section of the text, one section of R, and we exchange the. So the R output here. So
like you had, you were changing your data each month to produce a report, and you wanted to say which class had the most observations. Could you embed that in a sentence saying the class with the most observations was?
I see. I don't know the answer to that question off the top of my head, and someone else looks like they
Yes. The command is /s expression, and inside the curly brackets you can put any and whatever the output from that is will just be dropped into that place. So like we use it all the time.
I'm just going to show you, in the interest of time, I'm just going to show you very quickly some of the differences in Knitr compared to a Sweave document. So all the stuff at the top is basically the same, the header stuff. All of the stuff underneath, in terms of the LaTeX, as you might expect, is the same. So this is just a table that I made up personally here. So one thing you'll see, this chunk of code here is drawing a Kaplan-Meier plot, so it's fitting a support and it's plotting it. And so I've named my code chunks in here, but there are no further options needed in Knitr to get your figures output. One other problem with Sweave is that each chunk of code can only have one figure output from it. Knitr, you can have as many figures as you like in a chunk of code. Other than that, maybe there's not much more to say about Knitr other than that personally I think it's a lot easier to deal with. Here you have the equivalent of specifying height and width for figures in a particular chunk of code.
You tempted us earlier on by talking about the Sweave options command up at the top. What's that about?
Good question. It makes a concordance file, which adds another file to my folder, which I have to delete later on, and I don't have to put it in the Knitr file, and that's about as far as my understanding goes. It's something to do with synchronizing your two files that you have, but I didn't actually look it up to see what it did. Okay. But you don't. So that's one thing about Knitr. Let me just change this over up here. Is that you don't need that in your header. So this is essentially. I just go. Oops. Wrong type of new file. So this is the new document here. So you only need these 3 lines for Knitr. So I mean, it's only 1 line less in that respect. But I think actually in terms of the other options, actually being able to have multiple figures per chunk, Knitr is considerably more straightforward. You can also, if I just scroll up to the appropriate point here, you can see in this header, I'm passing a caption for the figure in this chunk in the header. And you can pass a vector of caption. So if you've got 3 figures in your section, you can pass caption 1, 2, 3 as a vector, and those will be output. The figures will be numbered appropriately. So from that point of view, it's a little bit more streamlined impact.
Can you pass an R variable?
I suspect so. Partly because we tried to run something before and said it didn't know what the hide object was. So if you have specified what your captions are as an R variable, yes. I mean, one of the main things about Knitr is it's supposed to be a lot more modular and tied into what's happening within R. I have a few more slides, thankfully, one of which is an acknowledgement slide and one of which is a references slide. I just put this slide up just to show you very quickly if you want to manually compile a Sweave file, then within R you can call Sweave on that .rnw file. That will create the text file with the same file prefix. So if you've got myfile.rnw, it will create this, running this command will create myfile.tex. And then if you can do this within R, or you can then take the text file elsewhere and LaTeX and compile it there. The last command is to tangle the file. We've already mentioned this, so these are really just notes on figure bits and pieces. So as I've said already several times, Knitr is considerably more straightforward than Sweave for figures. I'm still pretty sure that if you're plotting in ggplot, which if you like good figures, you probably are, that you need to print your ggplot object in the same way that if you're running ggplot within a loop, that you need to print within that loop as well. So we've already seen some of these options as well. So these are just notes really about things that we've already done. This is a note about X table, so to get a nice LaTeX table from an R object. So in Sweave, if you want to use X table, remember, if you call that in the R console, it will basically print out the commands that you need to create the LaTeX table. So in Sweave, you put in the header results equals text, and it will then interpret that code as being text, and the equivalent for Knitr is results equals as is. And so if you then run that print text table command down here, that will take the LaTeX output from each table and format it correctly. I only really started looking at child documents today, which you were kind of alluding to earlier, so I just put a link up to child documents here, but it is possible to compile several documents into one as well. So we can do the acknowledgements. Thank you to the researchers whose work has formed the basis for our practical examples and inspired the need to get something that easily gets output into a shareable format. So I just had a few slides at the end. I mean, if you want help on LaTeX things and R things and Knitr things and Sweave things, and you know the specific problem you want to solve, I mean, cross-validated, not cross-validated specifically, but the Stack Overflow series of websites are really good. So there are text ones as well as programming ones that deal with R. As we've seen, RStudio simplifies the compiling options somewhat, so it does streamline the process, I feel, a little bit in terms of what we like to do. And the other main resource that I've used in terms of LaTeX over the last few years has been one of the wiki books on LaTeX. There's some quite good stuff on structured documents and so on. So I think we may or may not have time for a few more questions, if there are more questions.
I found this week receiving editor called Bakapokoma, something like that. Have you used that one, and can you use it to look at the mixtures of R and LaTeX code just to do real-time editing on in Microsoft Word? It's a system that shows two windows, and top window shows document as it's printed, and you can change bold and italics and do whatever you want in Microsoft Word type patterns and so on. And the bottom line, bottom window shows then automatically inserts the LaTeX command.
Okay.
That looks very nice. It seems to be the only receiving editor. Has anybody used it?
I think when I started using LaTeX, I tried using a GUI environment for some bit. I mean, you could certainly use that and then copy and paste your LaTeX sections over to RStudio if you wanted, if you want a sort of integrated solution there. To show you, there's this little format button up here for LaTeX. So these different options up here, so sections, subsections, bold, italic, quote, and bullet list, and so on, do at least give you relatively quick access to the command if you're not familiar with the commands. But once you know a few of the major commands, you're pretty
If a person who needs to proofread and next time change is not a LaTeX expert, what do you do?
Good question. If I had one of those people, it might make life a bit easier in some respects. I don't know the answer to that.
So, with respect to that, Paul Morrill at Wellington University's got a project underway specifically to address that problem. I don't think it's solved.
Not export to Word and then back from Word to LaTeX?
No, actually, he wants to go through marketing. But yeah, there's no easy solution for that.
There's an page called R to Word, R to WD, which translate R code to something similar, but just writes a document on top of it. That does use a little of the LaTeX syntax of the writes a document. That might be easier, if the reader writes a document and send it off for easy. Proofreading or adding comments later on, and things like that. But that's just for users. It's not as
Yeah, I guess from a circularity point of view, if you're creating these documents to have something that's kind of standalone and reproducible, I mean, one option would be you could hand off the text file once it's created to the other person, and they could edit it in this other environment that we were talking about. Then the issue is just reintegrating that back with the original stuff. So it's possible that you may actually be able to open up this document and it would handle the text file and just not know what to do with the R code, and they could just ignore those sections. So we might be able to try. Or it might be.
All right, thanks, James and Jack.